Hello students, we're here in Unit 2, and the first section in Unit 2 is about inductive reasoning, finding counterexamples, and explaining why statements can be false. Alright, so in this unit, Unit 2 is all about logic, reasoning, and proof. Alright, so in your typical math class, your algebra, we're finding x, we're talking about shapes and geometry, and we got all kinds of math, the arithmetic. Right now, this unit's more about thinking, all right? And a lot of it can be done by just thinking. This is a very different math unit than you've ever done, but it's very interesting. It helps develop our brains. And you know what a good life skill to have as an adult is? To have logic, is to have reasoning, all right? If you look at adults nowadays, a lot of them believe in silly conspiracy theories. They think the world's flat. They never develop their logic and reason. So very important unit just for your life in general. So introduction. The term inductive reasoning refers to reasoning that takes specific information and makes a broader generalization that considered probable, while still remaining open to the fact that the conclusion may not be 100% guaranteed. In other words, you're making an educated or informed guess based on the information or data that you have. It might sound right, but that doesn't mean it is right. Together, let's explore some examples of inductive reasoning. You'll quickly see what it's all about. All right, so examples of inductive reasoning. I like to eat hot Cheetos. My friend likes to eat hot Cheetos. Therefore, everybody likes to eat hot Cheetos. All right, it's a fact that people love Flaming Hot Cheetos, but it's a fact that not everybody likes Flaming Hot Cheetos. So you can see that based on that, just because you like Cheetos, your friends like Cheetos, doesn't mean everyone does. Or Mr. DeShetler won Teacher of the Month, so he'll surely win next month as well. Mr. DeShetler is a really good teacher, but will he win Teacher of the Month every single month? Probably not. And last example, it was 20 degrees outside when it snowed, so I think it will snow next time it is 20 degrees. All right? So just because it's 20 degrees out doesn't mean it will snow. So these are cases of inductive reasoning which all turned out to not be true statements. Inductive reasoning still can be true. It's just not 100% guaranteed. And here's a funny cartoon. All cats have 4 legs. I have 4 legs. Therefore, I'm a cat. This silly dog. This is a dog. All right? We'll name this dog Rufus. Rufus the dog. Being silly. We'll give him purple eyes and sharp teeth. Ooh, Rufus. It's a little bit scary now. Okay, so examples of conjectures. Are these true or false? So first off, let's actually jump down here. How do you prove that a certain conjecture is false? You just need one counter example. So, in this first case right here, an even number times an even number is always even. Well, let's just think about some things. 2 times 4, 8. Let's pick some other even numbers. 6, 10, 60. 8 times 12, 96. It appears true. We saw 3 cases where it's true. How do we prove a certain conjecture is always true? We need to prove that it's true for true for all cases. And this can be somewhat of a daunting task, because how many even numbers exist? Well, there's an infinite amount. So how would we just spend the rest of our life doing an infinite amount of cases to prove that an even numbers times an even number is always even? No, that's pretty boring. We would so when we prove something to be true, we have to be clever. All right, so not only are we going to improve our logic skills, our reasoning skills, but we're going to learn how to become clever and how to cleverly think. Also, some fun facts. For all, mathematicians hate writing that word. Upside down A means for all. And in fact, just a little fun fact of the day. This means for all x, there exists a y element Actually, hold on. I even messed up. So this is a math sentence right now. For all x that are real numbers, there exists a y that is an integer such that x times y equals 0. So that's a math sentence. If you go to college, this is how you write sentences. For all x that are real numbers, there exists a y that's an integer such that x times y equals 0. But that's just kind of a fun fact. That looks scary. Alright, I'm very frightened by that. If you want to learn more, go to college and major in math. Alright, a negative number times a negative number is always a positive number. Alright, so I'm back up here. A negative number times a negative number is always a positive. Alright, so let's think about like negative 1 times negative 6 produces 6. Negative 3 times negative 5 equals 15. So this is actually true as well. We're not going to prove it to be true right now. But a negative times a negative is always a positive. And one way to remember that is when a bad thing happens to a bad person, that is good. Such as when someone steals, so a burglar, a robber, they're a bad person. They have to go to jail. That's bad. That's not fun. It equals a good thing though, because we got the bad guy in jail. And then an even number times an even number is always odd. Or even times an odd. So let's do this. Let's do 2. That's an even number. Let's do times 3. That's an odd number. 6. Always odd. No. This is false. Alright, this is an example of a counterexample. It's a certain case that proves that the sentence is not true. Alright? So this whole statement is false because all we need to find is one counterexample to make the whole thing false. It might be true in a lot of cases, but if it's false in one case, the sentence itself becomes false. Alright? So let's look at this right here. Determine if the statement is true or false. If false, provide a counterexample. If you live in Ohio, then you live in the United States. That's true. Ohio is in the United States. There's no parts of Ohio that exist outside of our borders. Now, this is kind of interesting. It's the same sentence, but we swapped the order. If you live in the United States, then you live in Ohio. Well, that's false. Why? All I need is one counterexample. You can live in the United States, but live in Texas. Okay. Now look, this next one's the same as sentence A, but now I put a not in both parts. If you do not live in Ohio, then you do not live in the United States. So basically saying the only way you can live in the United States is if you live in Ohio. Well, this is also false. Why? You could live in Florida. If you don't live in Ohio, maybe you'll live in Florida, and you still live in the United States. And the last one, if you do not live in the United States, then you do not live in Ohio. So if you don't live in the United States, that means you live in a different country. So there's no chance you can live in Ohio. So that's true. Alright? Answer these follow-up questions. Looks like a lot of fun. And then join me back with the video about patterns.